All right, this is our Diels Alder masterclass, all right? We on X Games mode now. Check this out. All right, well, what are we even looking at? The one on the left we should be pretty comfortable with. This is our conjugated diene. All right. We have an electron withdrawing group. A lot of times you see in the dienophile, but we also have an electron withdrawing nitrogen in our dienophile. Remember, if we can get a negative charge here, if we can get a positive charge here, then we'll be good to go, okay? Remember, our conjugated system is going to look like that. And without even doing anything, remember, our end result is going to mimic or is going to resemble our conjugated system, but with a double bond between 2 and 3. Whatever was attached is going to stay attached. Okay? That's half of our answer. Most of these are going to form 6-membered rings. Okay? So, we're not used to looking at something, this heteroatom, this nitrogen stuck between all these carbons. And in the book, technically, it said that a dienophile was supposed to be a carbon-carbon double bond. In this case, it's not. In this case, he's throwing us a curveball and is giving us a carbon-nitrogen double bond, okay? But that's still going to be the double bond that approaches our answer. So we can come up with both products right now, and then we just need to decide which one is correct, okay? So, let's go back, because we're going to do our 3 brothers switcheroo. Here comes our double bond. It just so happens to be attached to a nitrogen, and there's a phenyl ring here, and there's an ethyl down here. Okay? 3 brothers are going to do their thing and all rotate. To there, to here, to here. Just going to clean this up a little bit. Okay, one of the possible answers, okay? But remember, well, why did it have to approach that way? Just because I drew it that way doesn't mean that that's the way it's going to approach. Can also come in, and really I'm just going to reverse everything, you know? And just picture in your head, just this whole thing, just turning around, just flipping. You know, this falling on its head and coming this way. This coming towards you and flipping. And in that case, our nitrogen will be here. This will be here. And our phenyl ring will be here. Okay. One of these is the answer. We know that. 2 of these are going to be the answer, options on the test, so you got a 50-50 shot now. It just so happens that this one is correct. And now we need to figure out why, okay? All right. So let's see if we can kind of game the system. If this just worked out and this simply just came over, the phenyl would be up top. But it's not. It's not. Phenyl is on the bottom. So this rotated. Let's see if we can figure out why, okay? All right, and let's see if we can maybe do this a little simpler than my last video. Remember, oxygen, 6, 5, 4, 3, 2, 1, 0. No charge. It is electron withdrawing. However, it does not have a double bond to withdraw from. So it is going to send an electron. It is going to send an electron, okay? So it's going to form a double bond, and we'll do a little ring around the rosy, and that happens there. And remember that ultimately this is going to hop here. This was attached to 2 hydrogens, and now it has a lone pair, 4, 3, 2, 1, 0. So we have a negative charge, which is great. That's what we want on our conjugated diene. Okay, well, what can we do with this dienophile? What can we do with this dienophile? If we can get a positive charge here, that would be great. Well, what do we have? Remember in all those other examples where we have an oxygen with a double bond and it takes the double bond? We can do the same thing with the nitrogen, you know? Nitrogen's not that far from oxygen in the periodic table, you know? The electronegativity number is what, like 3.0? So it's still electron withdrawing. So it's going to pull electrons from that pi bond, 5, 4, 3, 2, 1, 0. Remember, it already has a lone pair, 5, 4, 3, 2, 1, 0. It already has a lone pair. Now it's got a second one, 5, 4, 3, 2, 1, 0, negative 1. We need a positive, but we just got one. Why? Because this carbon, which was attached to 1 hydrogen, and still is, now is only attached to 4, 3, 2, 1, and has a positive charge. There's our positive charge, okay? All right, so now you can kind of see where we're going here, because remember what I did in the last one. If we take this and try to attach it to this negative, we're not forming a ring. This is making this longer. This isn't forming a ring. This needs to rotate in order for everything to kind of line up, okay? Just knowing that this has to rotate, you can figure out that phenol's going to end up on the bottom, and you can get to this answer without having to do all that extra work. Just by seeing that, to line up these charges, a rotation makes better sense, makes more sense to make a connection. You can figure out that this bottom left one is your answer.